Welcome to the Explainer. Right now, there's a silent, digital war being waged across billions of connected devices. And yeah, that might even include the one you're watching this on. Today, we're going to explore how artificial intelligence is becoming our most critical, most essential frontline defense.
Okay, let's just dive right in with a question that, honestly, hits pretty close to home. I mean, think about it. Every single smart device in our lives, from our watches to our home assistants, is a potential open door for an attacker. The convenience is amazing, we all love it, but it definitely comes with this hidden cost, vulnerability.
All right, so here's our roadmap for today. First, we're going to tackle the sheer scale of the problem. Then, we'll look at how AI is stepping up to be a kind of digital guardian. After that, we'll see how these new defenses are actually being built, and then check out the blueprint for a truly secure future. And we'll cap it all off with a real-world attack scenario so you can see it all in action. Okay, so first things first, we really need to grasp the scale of this battlefield. And look, we're not just talking about a few computers here. We are talking about a global network of billions upon billions of smart devices. And frankly, a lot of them are just wide open to attack.
It's kind of like a chain, right? All it takes is one single weak link. Maybe it's a vulnerable sensor in a factory, a connected car, or hey, even your smart thermostat. And that can let an attacker compromise the entire system. And this isn't some far-off futuristic threat. This is happening right now, today.
And the challenges here are they're immense. It's not just about worrying about data privacy. We're dealing with these incredibly complex systems that, let's be honest, were often built for convenience first and security as an afterthought. Trying to go back and patch these smart environments is, well, it's a monumental task.
So the big question is, how on earth do you possibly defend this vast, complex network? Well, that brings us to our first line of defense, where the good old-fashioned security guard is getting a massive, massive AI upgrade.
For years, the go-to answer has been something called an intrusion detection system, or IDS. Its job is pretty simple, really. Watch all the traffic flowing through the network and just sound the alarm if it sees anything suspicious. It's an absolutely crucial tool, but yeah, that old model is really starting to show its age. And this right here perfectly illustrates the massive shift that's happening. A traditional IDS, it's like a security guard with a binder full of photos of known criminals. If a brand new threat shows up that's not in the binder, they might just walk right on by. But an AI-powered IDS, it learns the behavior of the network. It doesn't just look for what it already knows. It looks for anything that seems out of place, making it way, way more powerful against new attacks nobody's ever seen before.
Now, what's really fascinating is that we're moving beyond just having a single general-purpose AI. It's more like we're building an entire team of specialized digital detectives, and each one is trained for a very specific task.
To get this done, researchers are cooking up these highly specialized AI models. Now, you don't need to remember the acronyms, but just think of it like this. One type of AI is like a bloodhound, trained to sniff out any general weirdness in the network traffic. Another one is more like a data scientist, specifically built to find these tiny, malicious signals that are hidden inside mountains of messy, normal data. When they work together, they can't just tell you if there's an attack, but often what kind of attack it is. But look, AI is not a silver bullet. It faces two huge challenges. The first is something called concept drift. Basically, the attackers are constantly changing their disguises, which forces the AI to constantly relearn what to look for. The second is class imbalance. Imagine trying to find one specific needle in a warehouse full of haystacks. That's what the AI has to do, find that one malicious piece of data among billions and billions of normal ones. So if even the smartest AI has trouble with this stuff, what's the answer? Well, it turns out having a smarter detective is only half the solution. To truly secure our future, we need to redesign the entire city it's policing, the very architecture of the network itself. And this is where this really revolutionary idea called software-defined networking, or SDN, comes into play. See, in a normal network, every little device makes its own decisions, but with SDN, you centralize all that intelligence. You create a single control plane, a master brain, that sees and manages the whole network. For security, this is an absolute game changer.
And what's really incredible is that this new approach lets you create a dedicated, ultra-secure, fast lane right inside the network. Think of it like a protected convoy or a VIP express lane, just for the most critical data. This is so essential for things like robotic surgery or automated factories, where even a millisecond of a delay or disruption could be, well, catastrophic. Now, the philosophy that governs this whole new architecture is called zero trust, and the name really says it all. The old model was like a castle with a moat. Once you got inside, you were pretty much trusted. But zero trust, it assumes the threats are already inside. So it is constantly verifying every single device and every single request. Nobody gets a free pass, ever.
Okay, this all sounds great in theory, but let's make it real. Let's take a look at how this new, intelligent architecture would actually handle a specific and, frankly, very clever type of attack.
A log poisoning attack is, wow, it's sneaky. You know how systems keep logs, right? They're supposed to be this trusted record of everything that happens. But what if an attacker could secretly write malicious code into that trusted record? Then, when the system later reads its own log file, it could actually execute that code thinking it's a legitimate command. Basically, the system gets tricked into attacking itself from the inside out.
But here's how our new system fights back. This is where all those pieces we talked about come together. That collaborative AI sitting in the central SDN controller, it spots the unusual log activity in real time. But more importantly, the zero trust model kicks in. It sees that the attacker's process isn't authorized to write to that log in that way, and it's blocked before any damage can be done. The attack is stopped right at the source.
So when you step back and look at the big picture, you see this incredible evolution happening in cybersecurity. We are moving away from this reactive posture, I'm just trying to identify threats we already know about, to a proactive, intelligent system that actually understands behavior, centralizes control, and trusts absolutely nothing by default. And that, of course, leaves us with one final and kind of sobering question. We are building these incredibly sophisticated AI defenses, but we have to assume that the attackers are doing the exact same thing. The next frontier in this war won't just be AI versus human hackers, it's going to be AI versus AI. And that's a battle we need to get ready for, starting now.